Hey everyone, welcome to yet another webinar of National Space Society Mumbai chapter. For those who are not aware of NSS Mumbai, we are a non-profit organization aiming to create space-faring civilization while promoting STEM and space with our various initiatives. Today we have with us a very special guest, Pushkar Vaidya sir. He is the head of Mumbai-based research organization, Indian Astrobiology Research Foundation, IARF. Pushkar sir is one of the world's leading scientists in the field of astrobiology with research interest in simulation, hypothesis, panspermia, and consciousness studies. He is also the chief scientist of two proposed missions, Bijayan Venus and Bijayan Cosmos. He has been involved in space science related ventures, including the establishment of IARF, renowned for his thrilling presentation as well as for his witty and engagement style. Uh, he is one of my favorite scientists, I would say, because he is the one because of whom I have reached till now, where I am right now. He motivated me to pursue my further studies for space and and especially into engineering. Without any further ado, let's get started with the webinar. Over to you, Pushkar sir.
Yes, thanks a lot, Prathamesh, and thanks for your kind words. So, welcome everybody. And I think I'll just get the presentation up. I hope I'm getting it up correctly. Just a minute. So, Prathamesh, can you see it properly?
No, sir, the presentation is not visible.
All right, just a minute. Can you see now?
Yes, we can just first slide.
Okay, you can. All right. Okay, sounds wonderful. Cool. So, yeah, welcome everybody. We are going to have a bit of a chat around terraforming. So we are using the word apology, in a very sort of ancient sense. So it's a bit of a defense, that why we must be doing terraforming. I think my enthusiasm for the title indicates, that I do not have a lot of great hopes for how humanity is going about stuff right now. So I think terraforming might not be a bad idea to look at. Now, there's something I would like to, bring it up front, that this particular topic, this is not just about science per se. Also, when we say STEM education and stuff like that, increasingly, as the toys get bigger, like the telescopes and your particle accelerators and stuff like that. So for you to do research, it is, it is becoming little, it's not as much easy that it's not much of garage research happening. It's not possible to do that most of the time nowadays. What it means is that science, is not, let's say, it doesn't have a fence around it anymore as it used to for quite some time. It is getting, there are, let's say, pathways for politics, for real politics, for philosophy and stuff like that to enter. And the future of science, involves that. So it will be naive, if you believe that you can do big science now and not be involved in real politics and stuff like that. And terraforming finds itself right at the center of those sort of thought processes. So, well, I think we all know him. So he's going to pop up a couple of more times in the presentation. Just remember, that as we speak, of course, there is a war going on in Ukraine, and Russia is, of course, on the move, and so on and so forth. What is happening there has some sort of implications for terraforming. So I'm, of course, not saying the usual stuff of there must be war and therefore we must terraform. It goes a little beyond that. So we'll keep that in mind. But just to keep in mind that how something like a war and something like a leader like Vladimir Putin, has implications for how we are going to think, and that's the important part. So we will sort of look at it. I'm of course hinting at philosophy. So the point is that my research is primarily involves two things. One is evolutionary biology. So most scientists, they come from a certain perspective when they do their research. So in my case, it is evolutionary biology and philosophy. So in that way, I'm a little old school. So I'm like a bit of I like the word philosophy. I think it's the most purest way of doing science. And then of course, the tool is evolutionary biology. What I like to do is, of course, astrobiology. So we look for life in the universe, the study of life, the distribution of life. And of course, it includes the search for extraterrestrial intelligence and stuff like that. So terraforming is very so astrobiology in its very broadest sense includes terraforming. Now, one of the basic statements of astrobiology, I generally draw from this particular quote from Arthur C. Clarke, the famous science fiction novelist, with whom I had the good fortune of spending sort of a couple of years when I was in Sri Lanka in Colombo. So what he says is that there are two possibilities: either we are alone in the universe or we are not, and both are equally terrifying. So well, I mean, being alone in the room or in on the street, I don't have to define that. One doesn't exactly feel very safe, if you like. And if you are not alone, and if you find some, let's say, funny kind of people walking around you, then also you do not feel safe. Feel safe. So the thing is that both these possibilities are equally terrifying. So whether we encounter intelligent alien life or we do not. Now the thing is that astrobiology, of course, attempts to answer these questions. So what you see in this particular slide, is when we did the first astrobiology conference in India. That was in October 2016, if I remember correctly. So you can ignore me, but others are the important people there. So we had the cosmologist, he's just no more. The one in the blue shirt, that's Professor S. N. Chitray. In the center is Henry Through, mission specialist for Pluto Horizons back then. And of course, in the previous suit is Professor Chandra Vikramasinghe, let's say one of the pioneers of astrobiology and stuff like that. That particular panel discussion, was revolving around these three questions: that how does life begin and evolve? Is there life elsewhere in the universe? And what is the future of life? The three fundamental questions that astrobiology deals with. So that is what it was about. So terraforming is, of course, part of astrobiology, and we'll be able to soon sort of get to that. But before that, we'll just have a bit of a look at the so-called frontiers of astrobiology nowadays. And those are how you use extremophiles, these are microbes, which sort of, let's say, refuse to die and can do very cool stuff. Synthetic life, how we can create life which is by definition not biological. Artificial intelligence, we not define that, how we can bring that together to enhance our biological, let's say, capabilities, and maybe hand over the world to them, and so that they can look after the world better, maybe. The so-called concept of singleton from next Boston, so an extended view of artificial intelligence. The simulation hypothesis, the possibility of none of us are real, in that we are all in some sort of a virtual existence, and parapsychology and stuff around extrasensory perception and stuff like that. The reason is that it is the most challenging and diverse field in the world today. The normal boundaries of science, are not enough to explore a subject as wide and exciting as well as dynamic like astrobiology. The reason being that we by definition are talking about the study of the origin, evolution, and distribution of life in the universe. Because Earth is a different story, you don't need much of these things. But we are talking about at a scale of the universe. Now, because of that, what happens is that, of course, we know close to nothing about the universe, although we do feel that we know a few things. So we need to be open to possibilities. And that's why, these are the frontiers of astrobiology. Whether do we have the courage, apart from the capability to indulge in some of these subjects and look for answers which are not available from traditional science or traditional scientific method. So, well, that's that. Very recently, I think about a year or so ago, not even a year, maybe NASA put out this, confidence level of detection, like a COLD scale, so to say. And this was done to ensure, that just in case we find life somewhere, that we are able to, let's say, report it in a non-sensationalization way, so that we are not sensationalizing the entire news and making it sound like Mars has life and stuff like that. So as we move ahead in astrobiology now, this particular part, that is, how did life begin and evolve, as we report on this life, stuff, whether it's Mars or whether it's down the line Venus and Europa or maybe Titan, this sort of scale might be used. So it is a suggestion from NASA. So astrobiology community is sort of, let's say, currently going around that whether this is the best way to go about it and what can be done differently. So it goes in the sense of detection of the biogenic signal, the environment, the relevance, and so on and so forth. So I think all of us might be aware of some of these controversies which have happened, in right from the Voyager times, that sometimes it gets reported that there's life on a certain planet, and then, the results get challenged, and there's a lot of bad blood between the researchers and so on. So this is an attempt, to let's say, normalize the whole thing and standardize how we report. Now, just keep this in mind also, just as we kept putting in mind that this sort of stuff has been done as we go and explore Mars. So this is all right on the front end of astrobiology as of now. We will go to the other aspect of astrobiology, which is the possibility that there might be aliens out there, intelligent extraterrestrial life. The fact that we did not find it is basically referred to as the Fermi Paradox. So in the summer of 1950 at Los Alamos, Enrico Fermi, famously asked his colleagues that, so where is everybody? So if our galaxy is supposed to be teeming with intelligent life, then why have we not made contact? This has come to be known as the Fermi Paradox. So, of course, this statement starts with the belief that there are life forms out there, intelligent life forms. Because otherwise, we wouldn't be asking the question, where is everybody? So if, let's say, if we have this webinar today, and we come around at around 7:30, and well, Prakesh comes around and Priya comes around and she discovers that there is no Pushkar, there are no participants, and that is when she or he will ask that, where is everybody? So they are expecting, the speaker and some of the audience to be there. They're not going to come here tomorrow 7:30, and ask where is everybody. The point I'm trying to make is that there was a sort of underlying belief, even the earlier part of the 20th century, that given the size of the universe and overall, we cannot be alone, and when we were not finding anybody, these sort of questions were asked. Now, we have moved in the right direction with respect to trying to answer that question, and it starts with trying to figure out if there is life-bearing planets out there, or at least Earth-like planets out there. So the first step toward that direction was the Kepler mission, which sort of, let's say, it just sort of finished its lifespan about a year or two ago, I guess, and now we have TESS as a replacement for Kepler. But Kepler happened to discover, more than 2,000 odd planets. Some of them, were in the so-called habitable zone. Now, one of the predictions which have come out of that is that about 100 million habitable planets are possible in our galaxy. Now, that is a big number, if that is true. So when you put it in the context of the Fermi Paradox, you tend to feel good that you're talking about 100 million. That's like a lot of them. And in a more realistic way, in around 1,000 light years around us, there has been a prediction made, or a suggestion by researchers, in fact, from Sid Sosta from the SETI Institute, that about 30,000 habitable planets might be around in around 1,000 light years from Earth. Now, 30,000 is also not a less number, because what we do seem to understand is that, in case there is even a small possibility of water being available in liquid form, life might just pick up. And that is a definition of the habitable zones. That if you're too close to your parent star or the source of energy from wherever you are getting it, then it's too hot and the water will vaporize. And in case you are too far away, it will be too cold and water will freeze. So you'll have ice or vapor. What you of course require is water in its very liquid form. So like the green zone there, the habitable zone. So the circumstellar habitable zone is a region around the star where the average temperature on the planet allows for liquid water to exist. Now, of course, we are very clear that, or we believe as biologists, that we cannot have water, cannot have life without water. There is a reason we call it Jeevan, back in India, because it is literally life. Now, the thing is that the habitable zones, as I said, about 100 million planets in the galaxy, about 30,000 odd, in the light years around. And still, we haven't found, anything necessarily with our little steady searches that haven't happened. Let's search for extraterrestrial intelligence. Nonetheless, to talk about the habitable zone a bit, depending upon the type and let's say, the strength of the parent star and so on and so forth, the size of the habitable zone varies over time, and how long the longevity of the particular planet can be there, and so on and so forth. But the bottom line is that we do require a planet, at least to begin with, to have an advanced civilization. As of last month, if I got this data correct, just under 5,000 planets have been discovered, and around most of them have come from the so-called transit method, where you have an object is going through against the face of the source of light, let's say the parent star, and then a small object goes in front of it, and if we observe that, we see a dip in the brightness. So it's like Venus transiting across the sun, so we see the little dip in the brightness because of the Venus eclipse in the disk of the sun, and we tend to make some calculation and we can figure out that there's some sort of planet, out there. So Kepler, detected planets that way, and looking at about 150 or 5,000 odd stars overall, and 500,000 stars overall. Now, the thing is that from there on, we of course want to look at terraforming. The point is that, see, this is not a small search, all right? This is not a small search. It is giving us a bit of an idea of Earth-sized planets. And planets, which are in the habitable zone as well. We are able to, for the first time, make some calculated guesses in that where do we stand. Given all of this, it does seem to be clear that Earth is, in a way, special. That it is not very common to end up on a planet like this. So there's something we need to be aware of. So where we began in the presentation, that there are two possibilities, that right now we appear to be alone. Now, in case that is the case, then we might want to think of terraforming. That is basically creating Earth 2. Now, the thing is that terraforming and stuff around that has a bit of a, let's say, it gets a bit of a pushback, from different lines of thoughts, and it is here, that what we are going to make a defense of terraforming. So it is a process of transforming a hostile environment into one suitable for human life. So that's the basis of terraforming. So we pick up a planet and we make it habitable for life, particularly human life. Simple as that. But one of the earliest mentions of the term terraforming was in a story called as Collision Orbit by Jack Williamson. Then it was, of course, famously used by Carl Sagan. I believe it was in the 60s and so on. And in its most simplest form, terraforming can be spoken of as climate engineering done to a celestial body. Now, on Earth, we are already sort of toying with climate engineering. So in a way, it is good that we are not actually doing it. United Nations has certain resolutions around it because there is a good possibility that we might end up weaponizing weather. And as the ongoing war is sort of telling you that if something can be used as a weapon, you can bet that humans will go ahead and use it. So we are, with our generation and the scientists, which will sort of come from here on. As I said, this is no more simply about doing your science in the garage and figuring out how exciting it is that when you mix chemicals and you get something else. We are increasingly getting involved with real politics. So terraforming is climate engineering done to a celestial body. So those celestial bodies, of course, where we can do something are present in our solar system. So the options, of course, are Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, and the moons are some of these guys. Now the thing is that what looks realistically, what we can do looks like Mars and Earth is something we can actually pull off. Looks like we can do that. Not Earth, I mean Venus. Mars or Venus is something we can pull off. If we do it on Earth, it will be called as climate engineering. And we are, of course, suggesting that it must not be done on Earth. That is one argument that why we must terraform outside, but we'll come to that a little later. So Venus and Mars are the options, and a couple of moons like Titan and Europa. Now, what I'd like to tell you is that we are going to, as I said, this is the defense of terraforming, so we are not going to indulge much into the various ways it can be done. But nonetheless, Venus is one such candidate, which is it's called a twin planet, sister planet. I mean, you can literally, more or less speaking, go and just land on Venus, and you wouldn't have trouble with respect to gravity. It's more or less the same size. Now that is a big deal because the life on Earth, the entire life on Earth, has evolved at 1G, whether it's a bacteria, dog, or you and me. So when we start living long term on planets like Mars and stuff like that, we do not know exactly how the effect will be. So Venus, in that context, is a very good idea. And all that we have to do is, well, basically bring down the temperature, and it has excess of carbon dioxide and stuff like that. So we can do that. Mars is our next option. It's more like a little coldy planet, and if we put some atmosphere into Mars, then maybe we can actually go and stay on Mars. And of course, one of the wild suggestions has been, can we transfer some of the atmosphere from Venus and move it to Mars? Now, just remember that all of this, is in a way it can be done, and there's a reason we want to go down the track of why it must be done now. So when we speak about the apology of terraforming, we are speaking in the terms of why it must be done now and not somewhere down the line, and not slowly and making scales of confidence level of life and so on and so forth as we build the case. So just keep in mind that these sort of things can be in a way done. It's not that we entirely don't have the technology. I'm sure you have famously heard that Elon Musk once declared that we can just nuke Mars and get stuff out, and there was a lot of furor around it. Keep that in mind. Of course, we have Europa. It's one of the Galilean moons, and we believe it has some sort of extensive ocean or something. So something we can pick up, and maybe it can be used to sort of a jumping highway, to like a gateway to go to other parts of the solar system. These are also places, just to be clear, where we might actually find life already there in some form in terms of microbial life. Now, whether that origin might be independent or not, we do not know. I personally believe, and about a decade ago, I had written a paper to that effect, that no matter where we find life in the solar system, it will not have it will have a common origin. It will look the same. So whether there's life on Europa, whether there's life on Mars, Venus, Earth, no matter where we go, it will all life, if and when we discover it, it will look exactly the same. So, so that was I sort of made that proclamation about 10 years ago. So let's see, when something shows up, I'll also find out. Titan is, of course, one of the other candidates, which we can, where there might be life. In addition to it, because it is having certain, chemicals, we might be able to raise the temperature and make some sort of a living possible. But for all practical reasons, the only two places where we can literally go and do something, pragmatically speaking, is Venus and Mars. Now, terraforming Mars, it is it's an interesting possibility. But as I said, this presentation is not about the various ways we can terraform. In fact, there's one of the famous trilogy about terraforming Mars, where the author goes about, well, in the first part, we land on Mars and go for some sort of let's say terraforming in terms that we first start staying in the cubicles, we get the supplies to Mars. So that's the first part of his novel, The Red Mars. And we set up the bases, let's set up some factories and stuff like that, much like the way Elon Musk is planning to do actually. So this transition is much like what Elon Musk wants to achieve. Then down the line, we look for Mars, where we have managed to, let's say, dig out enough water, clear some sort of an atmosphere, and we are able to grow food on Mars. So we can have some plants and stuff like that, and we have a little greenish Mars. And then the blue one, where we have an entire moving ecosystem, where the planet and the denizens of the planet are living together and happy, and we can literally have a Mars of that nature. Now, no one exactly knows how long this will take. The estimates go from a few hundred years to maybe a few thousand years and so on and so forth. But the thing is, we can sort of think about it. It is not something which is how the hell do we do it. We sort of know what to do. The question is that when do we do it and how quickly we do it and why the hell do we do it at all? So in terms of Mars, it is mostly about terraforming the atmosphere, where you, in all cases, for that matter, is about terraforming the atmosphere primarily, where you sort of give Mars some sort of an atmosphere, and so that its greenhouse effect is brought up. Basically, it's able to retain some heat, and then we are able to create a fertile soil, and then we are able to grow some crops and so on and so forth. But as I said, we are not going to delve into various ways of terraforming. But the idea is, well, we can begin with, we can start in something like this fashion, where we are growing the stuff in some sort of enclosed containers. And then down the line, we are able to grow them directly on Mars and make it a green Mars. Terraforming Venus, well, that's of course my favorite planet, because I believe that gravity is the most important determinant. Because once we go and start staying on Mars, the issue here is that we won't be at 1G, and we already know that once you're in microgravity, the gene expression changes. So it will be interesting to see, how human beings and our microbiota in our guts and everywhere, how does it adopt, and what sort of effects it has on us. Because it's one thing to live in a biosphere for 45 odd days. The experiments which are ongoing right now, where you can sort of, let's say, mimic a few conditions, but you cannot mimic gravity. So as far as I'm concerned, Venus is a better bet if you want to terraform. So just about a week ago, I think a paper was published, suggesting that one of the ways to terraform Venus, that that you have an artificial Venusian surface. So there's that Alex, his paper was in the Journal of British Interplanetary Society. He's suggesting that we do not touch the surface at all. Instead of that, we create sort of not like a Dyson sphere, but sort of a floating artificial surface around Venus, and we sort of start living in the clouds of Venus. So a suggestion, I think it is sort of building on maybe what Carl Sagan said, but and sort of an interesting suggestion, that by means of a floating artificial surface, so we hit of an entire planetary surface. So, well, I mean, that is one way of sort of looking at it. Now, we also have sort of, let's say, toyed with terraforming Venus. And there are a couple of missions we had proposed as an organization. The second one of which we are not going to speak of today, which is Bijayan Cosmos, is something we are in a way. Let's say we can actually pull it off maybe around 2025 or 2027 if things go our way. But around 2017, we had proposed a mission called as Bijayan Venus. The intention was, and is rather, to trigger discussions and to ask some difficult questions to researchers and scientists, especially how the cultural aspect comes into being, and something which we are going to look at. So our idea was, that we send a crash mission to Venus. We put it directly in a heliocentric orbit. So basically, your rocket is going up, and there's a particular orbit, which we might be able to get ourselves released at, so that instead of requiring a parking orbit or anything of that sort, the nano spacecraft, like literally maybe a silo of a basketball or something like that, or maybe more, it directly goes on its way to the sun in such a way that it will be intercepted by Venus in the sphere of influence of Venus. Eventually it gets captured, and then it crashes onto Venus. That's the idea. As it tends to crash, it will sort of open up its content, and that content is supposed to be microbes, extremophiles to be specific, extremophiles, organisms that thrive and may require physically or geochemically extreme conditions to live. And Venus is, of course, offering such extreme conditions, and we have a good library of extremophiles back on Earth already. So we know where to stay in deserts and volcanoes and sea vents and so on and so forth, or the hot springs and stuff like that. So these conditions are always detrimental to much of life on Earth, but these extremophiles, they just love it. And the idea was that we take some extremophiles, we put them in a container, we put the container in maybe like a nano spacecraft, we send it on the way to Venus, it crashes. And then, of course, we hope and pray that that they survive, and we believe that they will survive because life has a knack of finding a way. Now, the thing is, when we made the suggestion and when we wrote a concept note about it, well, it was not exactly so well received. It was like, well, we are contaminating Venus and so on and so forth. Something which we will look at in the context of this presentation now. Because of course, there are aspects to this question. But all that I'm trying to say was the idea was that these extremophiles, there is specific extremophiles which will eat sulfuric acid. So we had acidophiles, microbes which will eat carbon dioxide, which is on Venus. And once you do all that eating, in a fairly long period of time, we can actually, perhaps bring down the temperature of the planet and so on and so forth. Now, the idea was to get going and doing something, and to suggest that engineering or mechanical stuff, is not the only way of doing it. Much of the Earth, not much, I mean the whole of Earth, it was not shaped by machines. It was shaped by life forms. Another thing is that nature is very patient. So the planets, let's say, we started about 4.5 billion odd years ago, and we believe life, as we understand it, has been around since at least 3.8, if not 4 billion years ago. By the time human beings came, at least modern human beings like you and me, it was just like they were 2 odd million years ago. So essentially, for about 4 billion years, the Earth was fine without us. There was no problem. It was doing just fine. The entire planet was shaped by microbes. And now to believe that, microbes cannot offer a solution when we want to shape, other planets, we thought that is just in a way ridiculous, and also a little not so respectful to microbes, because they can achieve stuff, which we cannot always predict, because that is life. It is not some machine. So that was the idea, that we put some microbes. Hopefully they love the feast of sulfuric acid, carbon dioxide, eat lots of it, multiply. And in fact, we can also check them out back from Earth if the mission succeeded or not. It's falsifiable, so to say. So this was the other thing about terraforming. So here you see there is an ethical question raised, that can we do it? Should we do it? And something which will come to down the line. So we now get into the part of the last part of the presentation, where we speak about what is the right thing to do. That why are we defending terraforming in the first place? Now, United Nations has a concept called as responsibility to protect. It's a controversial concept, and it goes something like this: that it is a global political commitment which was endorsed by all member states of the United Nations, and it says that one can intervene in the, let's say, in a way, in the sovereign affairs of another country to prevent genocide, war crimes, ethnic cleansing, and crimes against humanity. Of course, as we will notice that we are already looking at some dodgy ground to one country can intervene into another country's affairs. Now, this one has implications for what we are going to do with terraforming. Now, responsibility to protect, these are its sort of three pillars. The protection responsibilities of the state. So a nation state is expected to protect its population. R2P also allows international assistance and capacity building. So let's say, a particular state is struggling with looking after its population. It has all the rights to request international assistance and capacity building so that, stuff like genocide, war crime, and those sort of things can be avoided or checked or curbed. And lastly, timely and decisive collective response. So basically, if a nation state or a sovereign state, is not doing enough as judged by the outsiders to prevent a genocide or war crime and stuff like that, then timely and decisive collective response is in a way allowed. So you can actually, intervene. Now, the thing is, the concept of responsibility to protect, it depends upon how you define the framework. Let's say that it also involves, in a way, protecting our planet, our species, by extension our future, by extension the science, and importantly our space. Because our space, of course, is the final frontier. And generally, when we write protect our planet, there's a LOL next to it, because the planet doesn't need protection. We need to protect the planet, so-called protection, so that we can survive. The planet obviously doesn't give a damn about us, and it cannot care less. But keep this in mind, that a lot of stuff is being done today in terms of climate change, because we are saving the planet and so on and so forth. You must look after certain species and so on and so forth. Now, we'll get into the arguments for, why we must not, let's say, do terraforming, or why we must do, but just keep these things in mind, the whole idea of responsibility to protect. Because the case which I'm making is exactly that we have a responsibility to protect not a sovereign state, but a sovereign civilization, which is us. And the species is ours, it is the human species. And that requires us to terraform. So I'm not doing anything different, than what United Nations is doing. It's just that our canvas is wider. So why terraform? Well, one reason is that humans mess up Earth so much. See, I even messed up the spelling of Earth. That we mess up Earth so much that it is no longer habitable. Now, that's not too difficult to imagine, and of course the background image is, let's say, indicative, and we can do it in various ways, and we are good at messing up the planet. So we can go the climate change way. We can maybe choose the quicker way of just dropping a few nukes here and there. So various ways we can mess up the planet. We can also mess it up in terms of playing gods, in terms of, let's say, too much of intervention in ecosystem changes, diverting rivers and so on and so forth, or maybe not caring about the soil. As I think Sadhguru is on a mission to save the soil, or as it happened in Interstellar, that you just run out of food. So we are good at messing up Earth, and we have various options. So it doesn't require any other reason why the hell should we terraform. We must terraform because we are going to mess up the planet. Now here comes the first thing to an argument, that why would you go to Mars or Venus to terraform when we are unable to take care of Earth? Because if we are not responsible enough to look after our own planet as of today, Earth, then what right or what belief, with what confidence do we go to a Venus or Mars and then hope, that we will do better there? Now, the short answer is that absolutely no. We must not be under any impression that we will do better, because that is what it is. We humans are. We are good at making wars, as we are doing one, live as we speak, and this is how we are. So we are not going to wait around, that we become all Gandhians and stuff like that, and then we go. That's not going to happen. So that doesn't make any sense to say that we must look after this planet first. We are unable to look after this planet. That's the reason we go and we create one more. The chances are we will mess up Mars as well. But then we have Venus. The chances are we'll mess up Venus as well. But we keep on going, because to be human means to survive. And well, another reason is that, well, we might just be very good people, and we decide no climate change, no nuclear wars, but maybe something comes from outside and gives us one big smack and we are out. So maybe we get an asteroid strike or something like that, and that's the end of our story. Now, or various things can happen where the sun just decides to blow hot a little more than it does, and we are then scorched. Various things can happen. The point is that we have been living in a very special period, even in geological scale, where the temperatures overall has been very nice to us. And as things begin to change, we do not know how will the human life will cope up with it. So it's one thing to survive; it's quite another to flourish. So we do not know. So it makes sense to just have, in a way, a backup. That we go somewhere and where we are sort of around. So that's another reason why we must terraform. But most important reason, and what I've given to you is a couple of philosophical arguments, by the way, that this is the primary two reasons why we must terraform. But what I believe is that these are not the reasons, which we should be terraforming for. We should be terraforming for the simple reason of survival of the species, a responsibility to protect not just the planet, but our species. And we cannot protect our species if we don't terraform. And right now, our species is in a bit of a trouble. Because let's say, let's say the atomic bomb was never invented. So we could actually fight nice wars, and we are good at killing each other. So we can, maybe kill a few million and stuff like that. So no problem there. But the thing is that we can get tired of killing and still a lot of us will be left. But right now the issue is that if you drop a few good bombs, then the whole thing goes like boom, it's gone. And therefore, the survival of the species has come into question. And whose responsibility is to protect, if not ours? And who can stop us from doing that? So it is one of those positioning of either you are with us or not with us. Now, there's a concept called as planetary protection. Planetary protection, so it's not responsibility to protect. Okay, it's a planetary protection. It's a concept out of hardcore science. Very much torchbearer is NASA. That planetary protection is a guiding principle in the design of interplanetary mission, aiming to prevent biological contamination of both the target celestial body and the Earth. So basically, if you're sending something to Mars, we are supposed to just sanitize it and before we send it, and that is what it is. Now we are going to ask some difficult questions, but just remember that this is the reason why we were criticized for our Bijayan Venus concept, okay, even a concept. And we did not have the 6,000 crores or the 600 crores required, but the concept was good enough to trouble people. The point is that it was looked upon as contamination of Venus. Now the question is that around 2020, 2030, if Elon Musk has his way, we are going to end up with the entire, about 50 or 1,000 people, about, I think, a few hundred, and by 2050, 50,000 people on Mars. And as far as my knowledge is concerned, human beings breathe. And when they breathe, they put out some microbes. We are going to put microbes on Mars in some huge quantities and in great variety. Do these concepts even make any sense anymore? At least, in the larger context, these questions needs to be asked, that who decided, who follows, and why? So is science all about now, you going to Leh Ladakh and picking up some soil samples, and some samples coming back to some lab and looking after it, and you discover some sort of a microbe and you name it? Is that what is science? Or has the whole thing now become more, is different now? Secondly, who is in charge here? Are we working as a species, or are we still working as America, China, Russia? And I think we all know we are still working that way. So who decides what is planetary protection? Now, of course, so when I said, about a decade ago when I wrote the paper, I'm already suggesting that planetary protection is not, it doesn't make any sense, because the mixture of, there's been a lot of transport of, let's say, so-called lithopanspermia. A lot of stuff have been, exchanged between various planetary bodies. So the chances are, we have already, let's say, put stuff here and there. But let us say it is a pristine condition, that Mars is very pristine, and if we just go to Mars and if we do something, and if we go to Venus and if we put our microbes, we are going to spoil the planet. Now, the question is that back home, we have a problem. And these are the two problems which we are facing. That we might screw up Earth, or Earth might get screwed up by itself. And we have only two options. One is one is Venus and one is Mars. Is this the time to sit back and debate on planetary protection, or rather to go and build a second home? Because to my knowledge, we have at least a few thousand planets, Earth-like planets, and a few million, according to research in Habitable Zone. We will find a lot of pristine planets. There is no doubt on that. Should we waste our time doing planetary protection when we should rather be doing everything we can to get these two planets more shaped for us? And then, of course, the entire universe and the solar system is available for us to do all sort of protection that we want. But, well, now philosophy, the thing is that, we are getting the philosophical arguments in a way. So generally it consists of physics, like physics has the physics of it, ethics, the study of morals, and logical reasoning. Now, ethics, of course, there's an entire, let's say, ecosystem devoted to so-called Astro Ethics. That what is supposed to be ethical in astronomy and cosmology? Is it right to do this and do that? And as I said, the perspective which I'm trying to put forth is that this is not even applicable here, because we are talking about survival of the species, responsibility to protect. We just go and we have other planets to do your pristine science. Right now we are trying to survive. But there's a lot of ethics there. In fact, lots of papers get published about astro ethics and how we should behave in space and so on. Now, if you look at United Nations Outer Space Affairs Treaty, the Outer Space Treaty, not long ago it said that you should not be exploring space for, let's say, commercial means. Well, now at least we have a couple of companies which are going to land on the asteroids, within in this decade, and make some money around it. What I'm trying to say is that things change. Who define these ethics? Who is following? So once again, I'm trying to say that now, when we are doing our science, when we are doing STEM, more importantly, we have to spread the message of courage, of asking what science was originally about. Do we have the courage? Do we dare to ask the questions rather than just follow? Because ethics now, it's of course something which has there's something called a moral absolutism, which we will look at. But before we get there, let's say philosophy. Now, much of this philosophical framework is coming from the West. Now, then what do we do? I'm in India. I'm not from the West. And I have a very strong philosophical cultural heritage. I don't see that reflecting in the, in the overall gameplay of science on a global scale. I don't see it anywhere. I see philosophy being the basis of all of the astro ethics from a particular cultural and context. Do I have to agree? Who is going to ask this question? Because if we want to do terraforming, it cannot be one nation, one culture defined, the stuff like that. So the thing is that right now it is monotonous. See, I'm not an expert on in Indian philosophy, but let's say this guy is back. Now he, see, I think you might have heard, there's a way Putin walks. It's a gunslinger walk. He puts his right hand as a move march and left hand is moving, and he looks pretty cool. So it is suggested that it comes from his KGB days, where his right hand is always around his hip to pull out the gun and shoot. It is something that has stayed with Putin for years. And mind you, he was a brilliant man in terms of his service, which he gave to KGB and stuff like that. And what he's doing right now, is a matter of debate. But that he was capable is out of, is not a matter of debate. Now, that walk has stayed with Putin. The important point is that long ago, in the interview of Putin about a decade or two ago, if I remember correctly, when he is asked that what does he not like, something which is not ready to forgive, and Putin says betrayal. If someone betrays Putin, basically they will be dead, and possibly they will be dead in the way Putin likes it, basically poison, in other words. All that I'm going to tell you is that Obama also comes from a cultural background. He was not from KGB. He doesn't walk. He didn't walk, with his hand on the hip, the right hand. Trump came from a different background altogether. These cultural backgrounds, they are with us whether we recognize them or not, and they are also there in science. And much of the science today is defined by the Western civilization simply because we are in a phase of time where that particular civilization has been doing really well. All is good, because we are talking, they're of course doing really well in science and technology. But now we are going back to philosophy here, because stuff like terraforming is not about science and technology anymore. It is about deciding what is the right thing to do. Do we go or do we not go? In that case, who is only one particular aspect from the globe to decide. All that I'm trying to say is that just as Putin comes from a cultural heritage which is different from the West and his upbringing, I come from a cultural heritage which is different from the West. I come from my own background, and I don't necessarily agree with the philosophical framework. What do I do about this? As I said, I'm not an expert of anything to do with Indian philosophy. But what I do know that we had some big stuff going on. And when it comes to philosophy, they better be even, be respectful, because we were fantastic at it. And of course, the point is that the Greeks were good at it. We're talking of a culture which was before that. We have something to say. I do not see any of this reflecting in the responsibility to protect in terms of terraforming, in terms of planetary protection, that why should we not go or should we terraform? Because we do have our own philosophy. So what I'm trying to say is that if we do not look at our own philosophies and bring it, or at least have a look at it to see what it has to contribute, please remember that the science which we are doing and the STEM which we are promoting is not something universally accepted one truth. It comes from a cultural heritage. This is our cultural heritage. The Chinese have their own, and these two great civilizations never had a chance to speak as the modern science and technology took over. But now, as we go into the aspects of philosophy and terraforming, especially, because we are making these moral decisions now, we have something to say. And all that we get is to be told that there's planetary protection. All I mean is that we need to be able to bring in our ideas. Metaphysics, that aspect is a part of philosophy, which we deal with two questions: what is ultimately there, and what is it like? Now we are the godfathers of answering these questions when it comes from an Indian philosophy perspective. Huge literatures created. So do the Chinese and so do the other civilizations. We do not seem to reflect in any of the philosophical, let's say, frameworks which come in astro ethics, astro sociological ethics. We don't even exist. And that is important to know, because I'm repeating that just because if you think that something is coming, please remember this, that a person and a civilization and a culture, there is a link there. So those ethics are from a certain cultural framework. And it is not absolute. And this is what is called as absolute. So there is a concept called as moral absolutism. Actions are intrinsically right or wrong. So the thing is that there is a moral relativism, and there are different versions of it. So should people be, if someone commits a crime, should we hang them or should we not? Is that penalty okay or is it not? Why should only one ethics be around? Who decides the ethics? Who decides the frameworks on which the science is built, which is drawn from these very ethics? Is there anything wrong if UAE executes 80 odd people in one day? Who decides? Maybe when there is one leader, there is no problem. But as Indians, are we really not okay with the death penalty? Maybe we are. Do we have to confirm, or do we don't have to, and so on and so forth? All I'm trying to say is that it is time to show up with respect to the philosophical aspect, because these questions around the terraforming, these are not scientific questions alone. The technology is scientific, that's hardly the problem, but whether to do something or not. For instance, when we say going to other planets and doing stuff like that, or maybe planetary protection, in our philosophy or in our way of thinking, we believe life as a cosmic phenomenon. We think everything is alive. Now the thing is, in the moral theory, there's something called as moral agents and moral patients. So basically, I'm taking action. If you are the victim or a part of it, you are a moral patient. Then there's a moral community. There's moral significance. So does something have a significance? Now, does a dog involved? Do we take care of the dog? And the dog doesn't say anything, but we still take care of the dog. We don't hit the dog, or the dog protests. But we expand that definition. Now now should I hurt the screen? Is it okay to hurt the screen of the computer, which is not supposed to be alive? Now this is called as moral expansiveness. So all these concepts, they exist. Now, when we start doing terraforming, remember we are going to set up a government on another planet. We are not going to just set up, stuff to live in. Who decides? What's the constitution? Can it only come from one cultural heritage? More importantly, this is not about. I just want to be very clear. This is not about saying, that we should also, let's say, put up a fight. Look at the loss. And look at the poverty, which the science suffers because most of the things only come from one cultural heritage. Just imagine the richness that will be brought in, if different cultural heritage, they come together, to decide what is the best way to go about stuff. In addition to it, we have a lifespan issue. I mean, generally speaking, for the first 25 years of our life, we are trying to figure out what to do. The next 25 years, we do something. The next 25 years, we are wondering what the hell did we do in the last 25 years. And if you are lucky, you might get another 25 years to God knows do what. But the planet, it took about 4 billion years to put us together. It is not in any hurry, and it works on astronomical lifespan scales and not even geological scales. How are we going to achieve terraforming? And Interstellar suggests think as a species. That's okay, fine. We are all going to be together. We think as a species. Even if we do that, how are we going to ensure that we continue doing what we agreed? I mean, how do we do that? You see this guy is back there? Because the thing is that right now, the president of US denied a no-fly zone over Ukraine, saying that it might start World War III. All right, that's a good idea. He said, but we are okay with World War III if a missile falls in Poland. So basically, we are about 15 miles from starting a world war. Because just in case one of Putin's missiles go a little awry, they land in Poland and we have a world war. Does it make any sense, to speak of these things when your ongoing leader of the free world, so to say, has basically a 15 miles, threshold? Think of the change which brought in was, if you know the presidents, if you look at Barack Obama, if you look at President Trump, Donald Trump, if you look at Joe Biden, they are different people. Now, if we are going to undertake terraforming of Venus, of Mars, are we going to afford different people coming together with different democratically, elected stuff, and they start defining, how do you build a civilization on another planet? So it would require a philosophy which is able to, take everyone together and move ahead. Now, I don't think that, given the wars that Europe has given us, that, it should come only from there. Who is going to ask these questions? Because terraforming is going to be a project which takes a few hundred, if not a few thousand years. And it can't be, going from left to right and center and left center and, liberal and so on and so forth. So that's a question which we need to ask. Therefore, so that we don't get into all of this mess, the best option is to just go ahead and do it. Because right now we require one backup, which is Mars or Venus. Let's not ask too many questions, because this World War is basically 15 miles away. So something, we can do. There has been some progress on that line with the Artemis Accords coming in, that we might just, it's a US-led thing. India has not signed up so far. But trying to get people together, to part to success, that we go and set up a base on the moon, set up a base across in the orbit of moon and so on, and then eventually, move ahead from moon to Mars and so on and so forth. Trying to get the world together. Now, the thing is that once we land on the moon, of course, it is guaranteed that, we'll be putting microbes on the moon, and so on and so forth. Now, Artemis is a step in that sort of a direction, but it is again a country-centric step, where we are still not thinking as a species, and definitely not in terms of the time scales and the overall global political systems. So all that needs to come together for terraforming. Now, therefore, because it is so difficult to sort of do, we should perhaps push for a terraforming of one planet, whether it's Mars or Venus, simply for the sake of it. And then we can sit back and argue on everything else later. Because as it is well known, that the dinosaurs become extinct because they did not have a space program. But as I like to say, dinosaurs were dumb, so they didn't have a space program. But we might be dumber than the dinosaurs, that we have a space program and we might still go extinct. And therefore, the best idea is to sort of terraform. And that, in all, was the apology of terraforming. So if you have any questions, we can take them.
It was a wonderful session. There are some questions in chat.
All right, so if you can read it out to me, that will be helpful.
Yeah, sure. Okay, so first question from Chinmay. Is Mars in habitable zone? If yes, then why life haven't started there yet again?
Oh, well, Chinmay, I think that's a rather easy question to answer in the sense that Mars is just outside the habitable zone. It just sort of makes it. Therefore, it is too cold. If it was a little more towards the sun, then it would possibly have flowing liquid water. But well, in the past, we believe, of course, it had some, it was a wet Mars, so to say, and there might be something, still under the planet, underground in the Martian surfaces, so kept in liquid state because of maybe, some internal heat sources. But for all that we understand, Mars is not in the habitable zone because the definition of the zone is flowing liquid water, and we don't seem to find it anywhere.
Next question is from Krishnendu sir. he says if we are to terraforming a cosmological body like Euclideus, where subsurface ocean is present, at the same time tectonics are in jeopardy, as plumes are seen in southern part only, what might be possible things to overcome the challenge?
Oh, all right. Well, hello, Krishnendu. So the thing is that I think the short answer is I have no idea what to say. Because I do know about that little moon. But then I think you require a planetary geologist, to give some sort of a proper answer. I don't know.
So there is this another question. Suryendra, sorry if I'm pronouncing your name wrong. Could you possibly elaborate on the details of the Europa Clipper mission? In your opinion, which moon or planet may be suitable candidate to harbor life apart from the Earth? One more question: why is Kepler 2b thought to be another potential candidate for supporting life? Is there any biosignature that tells us of the existence of liquid water on the planet?
Oh, well, not actually. With respect to the Kepler stuff, we do not have any let's say very clear biosignatures so far, not even in biochemical signatures. But the positioning and the overall evolution of the planet, as we understand it, it is indicating that it might support flowing liquid water, and and that's where more or less it is. So what we are looking for is planets which are possibly having flowing liquid water as of today, and not necessarily from the geological past. Because if they have it today, then we know a little bit of let's say biochemical signatures which we can look for. But presently the jury is out. We are not so sure, and that's one of the reasons that this NASA scale was suggested. That now in case that the same thing is being reported, it will be reported in some sort of a level of confidence, so that we have better understanding.
One more question from Krishnendu sir. What are the factors that decide that if a natural satellite of a planet is going to be tidally locked or not?
Oh, well, once again, I don't think we exactly know that answer, to be honest. Because of course, we have certain cases with Pluto and something to do with, let's say, the Jovian planets and so on. No, I don't think we know the correct answer. Is my understanding. I, of course, don't come from necessarily cosmology to answer that. Having said that, in astrobiology, when you come from the possibility of intelligent design, not so welcome in in mainstream science, but the possibility that we might be in some way installed by some alien civilization, an expanded view of so-called zoo hypothesis. Now, keeping that in mind, our solar system seems to be not so common, with our tidally locked, in a way the way our moon is placed, as well as the way the gaseous planets, the positioning of the rocky planets. So we are an exception to the rule, and not that we haven't found solar system like ours, but then we haven't found anything which even closely resembles ours. So I mean, from an astrobiology perspective, one of the wild hypotheses might be, it was designed that way. But from a perspective of a simple, let's say, planetary physics, I'm not so sure.
There is a question from Ruchira. Will genetically engineered humans capable of withstanding Martian environment be potential way to terraform? And if yes, will they be referred as Earthlings or first generation Martians?
Well, so as Elon Musk goes to Mars, one of the issues is that what if someone kills someone, and if there's a murder charge, then who gets to decide which law is applicable, the International Court of Justice, or what do we do? Now, the reason I bring that up is that when we are going to get humans up there, we don't know who gets to decide who is Martians or who is Earthlings. So that is one sort of a problem. That will Martians be treated as the let's say, second-class citizens of the solar system. Something human beings are doing and are good at, treating people badly. So maybe we will be doing that, and therefore, and a philosophical framework is required. Having said that, the thing with genetics is that we understand close to nothing about it. That's one of the big problems. That it looks pretty impressive as of now, but then we hardly understand why certain genes express and why some don't. Now, when we go to Mars, what we are going to be first interested is to see how, when we actually reproduce on Mars, most importantly, when we have a generation, which is born on Mars, we'll have to see how the gene expressions come about. And it is not, of course, we already know that as microbes go in space, their gene expression changes. And we have seen that also happen to a little bit of one of the astronauts also, that there's a bit of a change. Not too much, but there is. So once the microbiota starts changing, we don't know how it will pan out. What I'm trying to say is that we are in no position to do any kind of genetic engineering on humans which go to Mars, simply because we do not know firstly the impact on us. Now, once we know the impact, thereafter, well, we might be in a position to find out. Presently, I think we are far away from it.
I guess that's a concerning issue that even if transferring ourselves from Earth to other planet, how are we going to actually control human beings in terms of crime, or if anyone prosecute someone or kill someone there? It's a big issue.
Yes, and I think we'll surely do that pretty soon once we land. So.
Yeah. So next question from Lokendra. What is characteristic property of extremophiles separate to other microbes?
Well, they seem to simply have mechanisms, which make them, let's say, withstand certain conditions. And of course, when I say mechanism, it does by default means that they have created biochemical processes which allows them to, let's say, withstand high acidic environments, or something like, too cold environments or too hot environments, and so on and so forth. So these mechanisms are, of course, one can look them up. But the important point being that why some of them are having those mechanisms, or is it evolutionary convergence? For example, we have this bacteria, the famous one, this Deonococcus radiodurans, which can sort of stand a lot of radiation, compared to what is generally found on Earth. So it has been suggested that maybe it is actually, it did not evolve to counter radiation. It was trying to do something else, but it just, as a side effect, it started to look after being able to, let's say, withstand high radiations. Now, the thing is that, so I'll just go to a little different aspect of extremophile, that some of them, are doing pretty cool stuff, especially stuff like tardigrades and water bears, where they can even, let's say, withstand space travel and so on and so forth. Now, it will be interesting, to see what happens, when they start living on Mars or on the Moon for a long period of time. Do they actually have some sort of cosmic origins? Do they start expressing genes, which we did not even know, dormant ones which never had any chance to, let's say, come about, but then they suddenly find themselves in certain environments, and they start expressing. Because these extreme conditions, are very much there in the larger cosmos. And if the hypothesis of panspermia is thought of correct, the possibility of microbes traveling from one part of the universe to other, if it is correct, then there is a more controversial hypothesis. It is called as cosmic origins, whereby it suggests that you and I are obviously the aliens which we are looking for, and that we have so-called cosmic ancestry. That not only we will have the extremophiles being the most obvious one, because humans cannot be going from one planet to another, so something like extremophiles, unicellular stuff, or stuff like that, they might be actually proof of cosmic ancestry, that we are incredibly ancient, maybe, that our origins came from somewhere deep in the Milky Way, and so on and so forth. So right now, as we study the different mechanisms of extremophiles, it is perhaps important to study them in the context of impossible cosmic origins. And then that's the beauty of astrobiology. You know, everything is possible as long as we are within the scientific framework.
I guess we are very near to find out if we have came up with the help of panspermia, because recently when the Hayabusa mission, I suppose, they brought back the samples back to Earth and they tested out. They found out that they had the basic elements that supports life. The dirt had that, so maybe that could.
So that will be wonderful. In fact, just a week ago, I think 4 or 5 days ago, a paper has been published, you know, once again to suggest the drastic mixing in the solar system of stuff which came from outside. So once again, you know, good news, you know, for panspermia.
Yeah. Real, if you have question, can you turn on your mic and ask? Was it just me, or you have team?
It's felt like a transmission from outer space.
Priya, your voice is kind of getting cartoonish.
Are we being contacted?
No, type your question. Till then, we'll go to other question. Question from Kevna. If we could manipulate our human DNA to be extremophiles ourselves and without actually manipulate the climate, and it won't disrupt the philosophy.
Well, yes. So it is that whole term is called as bioforming. So instead of terraforming, you know, so where we actually you know change ourselves instead of changing the environment. So we do believe that the ideal way of going about stuff is going to be a combination of bioforming as well as you know, terraforming. Now the issue here is that so for right now we cannot even figure out how to let's say fix our own bodies. We require spectacles. You know, so we can't do anything to make our eyes go proper. And you know, so we can insert stuff from like outside. We can put up you can get one of the cataracts removed for the elderly people and stuff like that. But that's all what it is. You know, we are not able to change our body in any meaningful way. There is an exception to this, provided we are open to the Indian philosophies. And I'll tell you how there is a qualifier here and how that might be important in terms of setting up a different civilization. The thing is, in our yogic system, there is something called as Nirman Kaya, where you can literally regenerate your body. Are we not going to take it seriously? If not us, then who the hell will take it seriously? The question is that you tell this to, and because I have interacted, you know, you tell this to someone from a Western cultural, you know, background, they think it doesn't make any sense. But well, when it comes to the matters of the mind, we do have the upper hand the way I look at it. Having said that, you know, how do you bioform? You know, because we can't even grow our hair right now. I mean, about 3 years ago, I had got a lot more hair, you know, and you know, I'm just worried it might just disappear. So the thing is that we can't even grow our hair right now, you know, back. So how do you bioform? But there exists a technique as of today. There are people who claim it exists, and it is called as Kaya Kalp. It's called as Nirman Kaya. Are we not going to investigate those parts? If not us, then who will? Having said that, these people, you know, these yogic people whom I happen to interact with, they have great qualifiers, immense qualifiers. Now, that is something that's missing in science entirely. In a way, it is there. You have privileged access, so not everyone gets access to all information and so on and so forth. But presently, we are in the open access sort of thing, that everyone should know everything. The yogic people are very clear that everyone is not eligible to know everything. So therefore, they say that let us say for the sake of argument, that something called a Nirman Kaya or the Kaya is possible, is true. Then if I can do it, if Ratnesh can do it, and if all of us can do it, what is the guarantee that we are going to do good out of it? And something the yogis are very, very clear about, that unless the mind is purified, you don't get access to these powers of physics. So what's wrong in that? So to stand up and say, that, well, if you can do it, show it. They're like, get lost, you don't deserve it. So the thing is that bioforming, from a genetic perspective, we are far from it. But there is an answer. But that answer, requires an entirely different courageous approach.
I recall one of your sessions where you have very beautifully explained the fact of the photographs of idols that we have or we accept as our idols or gods. They raise from behind, and you said that there could be some super intelligent beings that can manipulate the rays of data and transform it into some sort of understandable language.
No, that is very true. I mean, even right now, if we just get out of our room and step under the sky, all the answers are falling on us. All the data which is required is literally falling on us. That's why we are then setting up telescopes and stuff like that, so we can capture the data which is falling, and then we know. But if you could do this with your mind, then the answer is not a problem. The answers are falling all the time. Can we ask the question? Do we have the mechanism to ask the questions? And these people claim they have it. And they are very sure that it cannot be handed over to certain type of people, which includes most of us.
So next question is by Siddhanta. How terraforming is useful for Mars becoming Earth-like planet?
So how is it useful in the sense? This question.
That's the question. Like how is useful? Like, I guess the question is self-explanatory.
Well, yeah, I mean, in the sense that I'm not much of a fan of Mars, so I think therefore we can try it on Mars first. And the thing is that we are primarily going to, I mean, as I said earlier, we are going to set up a civilization. Now, it is primarily helpful not from a science and technological perspective, because as we have already seen, human beings are good at that. When we are given challenges, we do rise in terms of the science and technology, and we do bring up solutions and we move ahead. So if we are going to stay on Mars, I personally don't think this is going to be a challenge of science and technology. We will figure it out in some way or the other. The question is that how do you transport a civilization from Earth to Mars? I mean, what do you take? Do you take plumbers? Do you take electricians? Do you take artists? Whom do you take? And who decides, and so on and so forth. So for the first time in our history, we are going to get a chance to start from scratch, and therefore that scratch must involve everybody on this planet, and also partly be humble enough to allow. See, let's put it this way: that not all philosophies on the planet are equal. It is not true. Just as not, you cannot say that all human beings are equal. It is just not true. Einstein was smarter than us, so Usain Bolt is faster than us, and so on and so forth. So we are not born equal. Similarly, not all philosophies are equal. There are better ones, and therefore, do we have the humility to say that something is better than mine, and go ahead, instead of trying to dilute it by saying that, what, we are going to mix everything together and then we come up with something. Now, these difficult questions, are going to all come up. And I think that's the primary usefulness of terraforming, because the machines we will put up is the standard operating procedure, which will be interesting.
I guess starting from scratch will give us a good chance of, going towards the good part of the technology rather than destruction of the planet.
Oh, absolutely. Yes, that's the idea.
Question from Anisha. Do you think that the current situation of war could become the cause of next mass extinction?
Oh, well, no, when I was in Colombo in Sri Lanka with Arthur C. Clarke, a gentleman who had this uncanny habit of getting his predictions right. And one of the things, so he often is called as a futurist for that matter, because he got a lot of his stuff right. Uh, so one of the things he had said to me was, that maybe, that Pushkar, that you might see a nuclear war in your lifetime. So the thing is that the way the things are going, it is impossible, I believe personally, that that we will not see a nuclear war. It's a question of when, rather than if at all. Because someone somewhere with all these things around, is going to mess something up. Just as we accidentally landed a missile in Pakistan not too long ago, we are fantastic at making errors as well. And well, if one of Putin's missile lands 15 miles ahead and in Poland, Biden is ready to do a World War III. And remember, the problem with nuclear holocaust is that your advantage is as good as the first strike. So if you feel that you are going to be attacked, so this is not a question like where you throw a stone and they throw a stone and that you can continue. It's not a war of attrition. It's a war of annihilation. So you better just wipe somebody out immediately. And that is the reason it is a deterrent. It is not something you can do a bit and then come back. Because if you bomb me with one tactical nuclear weapon, which is what Putin is actually threatening with, so he's not saying I'm going to put a bomb on you, but he's saying I might use a tactical nuke. Now, once you cross that red line, you just require some hotheads to say that, well, he has put the smaller one. Before he puts the bigger one, let us put the bigger one. Now, when they put the bigger one, the other guy, doesn't have much chance, so he puts all the stuff, and therefore it's a very common human behavior. So that's the reason we terraform, because we can't trust us. Yeah, so we are we are very much in a realistic possibility of the nuclear war. We very much are, and there's someone who is willing to use it. And what's the point of making that if we don't use it?
I agree with you. So Aryan asks, can we use bodies in the asteroid belt to culture or store or microbes or materials for further terraforming expeditions?
Oh yes, very much. So these cosmic reservoirs or cosmic repositories. It's a sort of a suggested concept. Whereby we what are called the doomsday bunkers. Back on Earth. I think we have something in Norway like a Noah's Ark like thing where you put like a seed from the plants that we know and some genetic material from different organisms that after the Russian and the US are done with the war and everything is gone, then we can slowly restart life and stuff like that. There is a cosmic version for that we actually store these things, not on Earth because well we might just sort of blow ourselves up, but somewhere out there. Now, we can pick up a few asteroids because they are smaller ones, easy to manipulate, get hold of. We have already done a few sample missions with comets and asteroids, and we put stuff into that, and we use it for terraforming purposes. So this solution has sort of been around, not necessarily from a doomsday bunker perspective, but it also serves that purpose. So it is something like the proposal of Gateway in the Artemis Accords, where you set up this little, let's say, like a space station-like thing, where which you dock, and then from there you go to Moon and explore and come back to Gateway and dock. So similarly, if you have your supplies stored in the asteroid belt or somewhere like that, you can pick up stuff on the way. In fact, Artemis 2 was going to have an asteroid mission as a part of it, but it is no more the case. So yes, so what he's suggesting is very much doable, and I think we might end up doing it actually.
That actually reminds me, I guess Israel did the contamination part first. They sent these tardigrades on the moon, and the things crash landed, and the tardigrades are there in hibernation.
It's like a high five for them. I mean, you cannot contaminate something twice, right? It's done now. So we can put everything there now, I guess.
Yeah. So question from Priyal. On new field of ecological management, do we need that on Earth, and do we need that on other planets for terraforming?
You mean ecological management?
Yeah, ecological.
Oh, all right. So, I mean, did I hear the word management? Did you say ecological?
Yeah.
Okay, all right. So, see, our experience has been overall, especially with respect to forest management, and in terms of how nature sort of figures stuff out, that we are primarily better off leaving nature to do what it does best. Now, in terms of managed forests and forests which are wild, we have data which clearly suggests that the wild forests take care of themselves. You know, they have their own ways and means which you don't understand. Because we are far away right now from understanding the interconnectedness of this all. So for instance, right now we have a very strange situation in forest management where we have so-called empty forests. It's called the empty forest syndrome. Now, the very basis of ecology is sort of in trouble because of that. Now, this involves a wonderful looking forest without the big game or without a fair amount of fauna. So the animals are basically missing. So you got a lot of trees and stuff like that, but the forest does not have animals and definitely not the big game. Now that is a big problem for ecology, that for us to believe, you know, that we can take out the animals and we can still have the green forest and we can live fine, we are, you know, walking into an ecological disaster. Simply because that over and over again we have been taught or we have been shown, you know, that once we start to mess around with stuff, you know, we don't always, it doesn't always go our way. But the problem is that we have courses for ecological management and forest management and so on and so forth, which gives you the impression that we are in control. And we are not in control. In addition to that, we cannot be in control. And that's one of the reasons, you know, when we suggested our, you know, the Bijayan Venus mission, we were very clear that we are not interested in genetic modification of microorganisms, because that can be done. That we can modify the microorganisms in such a way that they are good at eating the stuff available on Venus. But we are very clear with that that is not to be done, because life has found its way for 4 billion years. It has managed the forest, and you know it will take care of Venus as well. And therefore, you know, when we go to Mars, and you know, when we start setting up a civilization, it starts from energy. You know, that where do we get our energy from? So one of the reasons, of course, these two guys are at war is also because of energy, and you know, whole world is getting dragged into that. So now that energy, you know, on Mars is not available. We all know that, you know, because it's a cold place. So it's a, you know, like an energy deficient planet. So how are we going to go about that? So now we will have an opportunity to create closed systems. What I'm trying to say is that if we are creating closed ecosystems, you know, then yes, we can live in bio bubbles. We can control everything. But to believe that we can, you know, control stuff in an open system, because remember, you know, here we are interacting with the entire universe, you know, because there are cosmic rays falling here. You know, we are not away from, you know, we are not cut off from this universe. You know, so if we set up a greenhouse and stuff like that, you can more or less predict how stuff will go on. So if we are going to do that, then it is fine. But if we are going to believe that, you know, we can control stuff in a natural setting, I don't think that's ever going to happen, and it's good it does not.
Well, there's this next question by Salil, and I hope, and I guess this is the last one. In your opinion, would our what would be your next step if Extremophiles fails to sustain terraformed Venus or Mars or Moon?
All right. So, you know, so that dropping Extremophiles on Venus, you know, is our original idea. Having said that, you know, NASA has already suggested that, you know, they would be using Extremophiles to terraform Mars. You know, they said, I think almost 5 to 6 years ago or something. I remember they suggesting that. And so the point is that we just take a helping hand. The whole idea, is that we take a helping hand from nano machines, which can basically multiply by themselves and gather their own energy. By of course that by which we are referring to the microbes. And what we know from lab experiments that as long as they get food, they do exactly what they do. They don't start to misbehave. So a microbe does what it does. So if all goes well for extreme environments, it's not a bad idea, to sort of start. And secondly, we do know that life will enable life. Uh, Once you put microbes, you're just not going to have one of them. Like for example, our DNA is mostly let's say junk viral DNA. So we sort of know that. But what we are not so sure is it actually junk. Now, much of this is, of course, in the microbes as well. So when they go to new environments, we really don't know, what games they start to actually play, in the longer durations. So they are a beautiful option for terraforming because we know they can be put in environments, where we can more or less guarantee that they can survive. And therefore we should perhaps bid goodbye to planetary protection as far as these two planets are concerned. We can go and protect the universe if we so wish.
So coming to the part of terraforming Venus, I suppose that you will be utilizing megastructures to cover it from the heat of the sun, right?
Yes, only thing is that requires a lot of money and a lot of politics. Microchips, I basically just throw it from here and they do their job. So that's the plan. Otherwise, yes, we do require some sort of a Dyson sphere-like setup to reflect. So that's one way of bringing the temperature down by not letting enough of sunlight to hit the planet in the first place. So you can sort of have a cover around Venus. So you bring down the incident sunlight, and by default the planet will start to, let's say, chill. But oh well, I think microbes are cheaper.
Yeah, I guess. Um, that that is all for today's session. So thank you so much for being here with us today. I'm very much honored by your presence. It was a very good session and thrilling as usual, as of offline sessions that you have. And I'm glad that we could do this session too. Yeah.
Thank you for inviting me. Thanks so much.
Thank you for joining, everyone. Please feel free to subscribe to our YouTube channel. We will post this session there. And if you have any questions, please reach out to us on our social media platform. And we'll forward those texts to Pushkar sir. And as he has already given his email ID there, you can reach out to him there as well.